Question 3. The question says, is the square root of the square of x minus 4 equal to 4 minus x? Statements 1 and 2 give some inequalities. Negative x times the absolute value of x is greater than 0, and the absolute value of x minus 2 is less than 4. Now you can think about a general strategy for data sufficiency questions in the GMAT. Always try to reformulate the question in simpler terms so that analyzing whether the statements yield a unique answer or not is actually faster and much simpler. So, what can we use in order to simplify the question? Well, let's remember that we have an algebraic equivalence or identity that the square root of the square of any algebraic expression y is always equivalent to the absolute value of that expression. Well, considering this, we could say that the question is equivalent to asking whether the absolute value of x minus 4 equals 4 minus x. But consider what 4 minus x represents regarding x minus 4. 4 minus x is simply the inverse additive of x minus 4, or x minus 4 multiplied by negative 1. So we're actually asking whether the absolute value of this expression is the inverse additive of the same expression. Let's simplify the question like this. If you were asked whether the absolute value of t equals negative t, what would you conclude about t? What should t be like in order to have this equality to be true? Well, this is equivalent to hold that expression t has a value less than 0, that is negative. Because according to the definition of absolute value, you have that the absolute value of a positive number is always the same number, but the absolute value of a negative number is the inverse additive of the number. So only when t is negative, the absolute value of t can be negative t. In other words, asking whether this condition is true is the same as asking whether this is true. Okay? So here in the original question, asking whether x minus 4 in absolute value equals the inverse additive of x minus 4 implies asking whether x minus 4 is a negative number. But asking whether x minus 4 is a negative number implies asking whether x is less than 4. So this is the question we have reformulated, and of course it looks much simpler than the original one. Now let's go for the statements. Statement 1 holds that the product of these two factors is positive. Well, we know that a product of two factors being positive implies that the two factors must possess the same sign. They are either negative or positive, the two of them. So, consider what is the sign of an absolute value. Is an absolute value negative ever? No, an absolute value is always greater than 0. So, for this product to be positive, the other factor, that is negative x, must be greater than 0 as well. But if negative x is greater than 0, then it follows that x is a negative number. So if x is negative, will x be less than 4? Obviously yes, because 0 is always less than 4. Any negative number will always be less than 4. We have an affirmative answer to the question, and so statement 1 alone is sufficient. What about statement 2 alone? We can open this inequality here using the template we saw earlier. So, the absolute value of any algebraic expression less than a positive constant k implies that the expression y must be between negative k and k. So using this identity, we can say that x minus 2 must be between 4 and negative 4. If we isolate variable x by adding 2 in each of the three parts of this double inequality, we will get x is greater than and less than negative 4 plus 2, that is negative 2, and 4 plus 2, or 6. So, if a number is between negative 2 and 6, obviously, we don't have a unique answer to the question, because x might be 5, negative answer. X might be 1, affirmative answer, to this reformulated question here. So, statement 2 alone is not sufficient, and now we have the correct answer choice. Among the 5 answer choices, A, B, C, D, E, and what they imply, we can see that the correct answer choice should be option A.